Let's start section 7.5, the last section of this chapter, solving rational equations. To get us started, let's take a look at our vocabulary term. The one that we have here is cross multiplying, nothing special. I'll show you how we use cross multiplying when solving rational equations coming right up. But right here, I do have a question down below, and it says, when does a function have an inverse? Okay, we've been taking a look at inverse properties for quite some time. And um, one way to check to see if graphs or functions have inverses, right here it says if it passes the horizontal line test. Okay, we've done the vertical line test, but not the horizontal line test. And so the horizontal line um, is pretty much similar to the vertical line test in the fact that the horizontal line passes through the function no more than one time. So if it does, and then there's no inverse. Okay, so it only, the horizontal line passes through the function only once. And then we know that we have an inverse right there. Okay, so that's why when we took a look at, let's say, our function, our hyperbola, when we have something like this, our branches, it passes the horizontal line test. It's not going to go through it any more than one time. So therefore, we know that there is an inverse right here. Okay? And remember, the inverse happens to reflect across y is equal to x. So let's get down to solving these equations. Okay. There's quite a few. We'll just get to some of the key ones here. Otherwise, we'd be here all day. All right, there's a lot to this section, so let's get started. Number one right here, we have ourselves two two fractions, and we set them equal to each other, almost like like a ratio, set up like a proportion. So right here, this is where you cross multiply, and I would go ahead and take like this 2 and this 2 minus 7, we multiply that together. We get ourselves 4x minus 14. Okay, and then we'll cross multiply the other direction, and then make sure you distribute the 5, and you get 5x plus 40. All right, and then we just go ahead after this, we solve for x. I'll subtract 4x to both sides, I'll subtract 40 to both sides, and I got x is equal to negative 54. Okay, and there you go. You do want to check to make sure that it works, okay? Otherwise, we're going to have extraneous solutions. So check your solutions is key. It does say that in the problem up at the top. I just highlight it right now. Check it, plug it in. Because once again, if you have if your denominator ends up equaling 0, then it's not going to work out, right? We have problems. Next up, let's go ahead and take a look at number 4. We'll take it one step further. You'll notice right here, okay, we'll go ahead and cross multiply. I've got negative 2x minus 42. That right there is equal to, well, we got x minus 9 and x plus 9 and x minus 3. Now don't forget, we have two binomials right here. So you are technically going to have to FOIL that out. So, whatever it takes, if you could do it in your head now, super. If not, then you better write out the two binomials and then FOIL it out. And so this becomes x squared. The outer is negative 3. The inner is positive 9. So we got ourselves plus 6x minus 27. And once again, all I ended up doing right there was FOILing, right? We got x squared minus 3x plus 9x minus 27. So I put that right there for you, and then we simplified that through. Okay? So on this problem right here, we do need to solve for x, but since we have a quadratic function, you're better off you got to set it equal to 0 and solve. So we got to move everything to one side. I'll add 2x squared to both, or 2x to both sides, so now I have plus 8x. Now I'll add 42 to both sides, and then now I have right here plus 15. Okay. Once again, make sure you guys show your steps. We got ourselves plus 2x, and then plus 42. All right. And then at this point, remember, we got options. Factor, quadratic formula, complete the square. So you take your pick on what you want to do. Okay. For the most part, factoring is usually the best and most of the time works. So factors of 15 that add up to 8. We got x plus 5 and x plus 3. And so when we set those equal to 0, x is equal to -5 and -3. All right. Remember, plug them in, make sure to see that they work, and if they do, we're in good shape. And guess what? They both work. So let's go ahead and move on. Let's take a look at step at number 5. Okay, things get a little dicey here because we have to figure out what is the LCD. So when I take a look at my denominator, 7 and x, I got to figure out, well, how can I get rid of my denominators? And what is the lowest common multiple of 7 and x? Well, that will be 7x, okay? One of the things that you could always do at the very least is take whatever the denominators are, multiply them all together, and that'll be your LCD. So right here, let's go ahead. It's 7x. I'll take the 7x and multiply it throughout everything. That's why I put in brackets. Okay, I put the brackets there to help you remember. You gotta multiply everything right here. So when I start, the 7's cancel out, and all left is 4 times x, so I got 4x. When I take the 7x and I multiply it with the 1 over x, the x's cancel, and now I'm left with just 7, with 7 times 1. And don't forget the minus sign. The last part right here, there's nothing we can cancel. So we got 7x times 6, and I have 42x. So lastly, we just go ahead and solve for x. I can go ahead and subtract 4x to both sides, and 7x is equal to 38x. So let's go ahead at the end, we'll divide both sides, right, by 38. And we now have our value for x. All right, and there you go. Let's take a look at another one right here at number 6. All right, so we have several denominators here, and we got to figure out, well, what's the LCD? I see two different binomials. We've got x plus 1 and x plus 2. Okay, those are the main ones. So we're going to multiply everything by x plus 1 and x plus 2. But what we're going to do right here is I'm going to go ahead and leave that as a binomial. Okay, I'm not going to FOIL that part out. Okay, so I'm going to go ahead and you can see how it looks like as is. And so let's go ahead and distribute this thing out. What happens here first is that, look, the x plus 1s will cancel out when I take our LCMs or LCDs. The x plus 1s cancel, so what's left is this x plus 2 and the 3. And so I'm going to multiply that and get 3x plus 6. We're going to take a look next with this. On this binomial or fraction, the x plus 2's cancel. So with the x plus 2's canceling, I'm left with x plus 1, and I multiply that by 4. So now I go ahead and I got plus 4x plus 4. With the last term right here, the x plus 2's cancel again, and then I take 15 and multiply it by x plus 1. So I got 15x plus 15. All right, so there we have it. We go ahead and solve for x, and then we get our answer. All right, so let's go ahead and combine like terms. That might make things a little bit easier. I've got 7x plus 10 is equal to 15x plus 15. I'll subtract 7x to both sides. And so I'll have right here 8x. And then I'll subtract 15 to both sides and end up with negative 5. Okay, so we have that right there. And then finally, let's go ahead and divide both sides by 8. And x equals negative 5/8. All right, there you go. Let's go ahead and take a look at the next problem. All right, next up, we're going to look at number 10. Okay, so this applies to a lot of different problems that you're going to be looking at coming up. But if you look right here, I've got x squared minus 5x plus 4. Okay, why is that important? Well, that's a trinomial, and typically trinomials are factorable. If I multiply, or if I keep that x squared minus 5x plus 4 and say that that's one of my LCDs, this problem is not going to work out very well. Okay, I'll just tell you that right now. It's going to get really ugly. You're not going to be able to cancel out a lot of stuff. So let's factor that out first. So if you see trinomials, there's a good chance that you're going to need to factor that out. So let me go ahead right here. I'll factor this. Factors of 4 that add up to negative 5. How about x minus 4, x minus 1? All right, because so now when you look at it, hey, there's already x minus 4 in my denominator. There's already x minus 1 in my denominator. So what I'm going to go ahead and do right here is take all of this and let's multiply it by x minus 4 and x minus 1. That is our LCD, right? The highest factors of each and every term. So hopefully now that we have that, things look like they're going to be a lot easier. Well, sort of, because we have like a binomial in the first term, and we're going to have to FOIL again. But hopefully we see right here, with this x minus 4, x minus 1, with the x plus 6 over x minus 4, the x minus 4's cancel. So what I'm left with now is x plus 6 and x minus 1. And don't forget, this part right here, you're going to have to FOIL. So I have x squared, outer is plus 6x, inner is minus x. So we got ourselves plus 5x. And then we have right there minus 6. Okay, so there's the first part. Now here's where things get a little dicey because we've got this minus sign. We haven't dealt with that yet. But what I would say is we could put a plus sign right here and then change that to negative 30, right? Add the opposite is subtracting. Well, there's not, now right here, luckily everything cancels out, right? X minus 4, x minus 1, that'll cancel out with the denominator right here. And so what I'm left with is now minus 30. Okay, because everything canceled out with our LCD, or our lowest common, multiple denominator. And then finally, for the last one, the x minus 1 cancels. And so now I have 3 times x minus 4, which is going to be 3x minus 12. Okay? So hopefully you're able to follow all of that right here. If I had a little pointer, I would, but it's kind of, can't have right and point and do all that kind of stuff at the same time, unfortunately. And so now we're at this stage, and then, well, we have ourselves a quadratic function, so we need to set this equal to 0. All right, so let's go ahead, move everything to one side. I've got x squared, and looks like the 3x, I can subtract that to both sides. So I have 5x minus 3x is going to be plus 2x. We got negative 36, and then I want to add 12 to that. Right? If we combine the 6, negative 6 minus 30, that becomes negative 36. And then right here, we're going to add 12 to both sides. So now we have negative 24. And that's equal to 0. All right. So once again, at this point, things are usually factorable. Factors of negative 24 that add up to 2. That right there will be x. And then it'll be minus, or let's have plus 6 and x minus 4. We'll go ahead and set both those binomials equal to 0, and x is equal to negative 6 and positive 4. Okay? Don't forget, make sure you check to see if you have any extraneous solutions. And, after all this work, you're saying, well, there's more to it? There certainly is. Okay, there's more to it right here. So I'll cut to the chase. And if you look at it, look at this 4 right here. If I plug that into the denominator of the very first term, guess what happens? It becomes undefined. Okay, so 4 right here is no good. Our actual answer and our only answer here, x is equal to negative 6. All right, so don't fall into the trap of not checking for extraneous solutions. Otherwise, you're going to get this. You did all the work, and you're going to get it wrong, or maybe only get half credit. Okay? So this is pretty much like the most difficult part of our problems, okay, where you're going to have to factor things out, and then you're going to, you might have to factor out a denominator and then try to work your way through and then solving out your problem. All right, let's go ahead and take a look at number 13. It says determine whether the inverse of f is a function and then find the inverse, okay? So just like other problems, if we want to find the inverse, you got to go ahead and switch x and y. I noticed on the tests in like chapter 6, some of you guys weren't really changing the equations correctly, and then you end up getting the problem wrong. So right here, let's go ahead. In the very beginning, that y, or f of x, should turn into x, and then we have ourselves y minus 3. Okay, remember, we are trying to find the inverse. That's what we're doing first. So we have our function. We're going to try to get y by itself again, all right, or solve the equation by y. So right here, let's go ahead. We can multiply both sides by the denominator, y minus 3, okay, and that cancels things out. So now, typically, we would distribute the x and try to solve things out. But I mean, we don't. That's not our goal right here. Our goal right now is to try to get y by itself. So there's no point in distributing the x. Let's just go ahead and subtract x to both sides. So now I have y minus 3 is equal to 8 over x. The last thing right here is we add y to both sides, or sorry, add 3 to both sides. And so this function will now become y is equal to 8 over x plus 3. Okay? And so what you're going to now do, what you're now going to perform here is this, the horizontal line test. Okay? So there's two things going on. All right? You're going to find the inverse. Okay. So find inverse. Step 2, graph the inverse. Step 3, horizontal line test. So once again with this, we got to figure out, well, where is the asymptotes? All right. Looks like it does shift up 3 units. So it's going to be up 3. And so if we were to kind of use my makeshift graph right here, we have that. H is 0. So we have this right here. And my function, if you go ahead and plug things in, if you were to make a table, and so you know where the function will go, it will look something like this. And does that pass the horizontal line test? It certainly does. And there you go. Okay, so is it a function right here? We will say yes. All right, the key thing right here is finding the inverse, though. What I care about the most is, hey, can you find the inverse? Do you remember how to do that? Switch x and y in the beginning. Some of you try to switch it at the end. Don't know why. Switch it in the beginning, and then solve for y, and go through your steps. Okay? The last problem that we're going to take a look at right here is number 15. These are work problems, okay? These are classic problems that used to be very big in Algebra 1, and now not so much, and we're going to see it. It's kind of been moved over to Algebra 2 a little bit more. So depending on your Algebra 1 teacher, maybe you already saw it, and if you did, you're ahead of the game. All right, let's go ahead and take a look at how we could put this all together. And it's actually pretty simple. It says you can complete the yard work at your friend's home in 5 hours. Working together, you and your friend can complete the yard work in 3 hours. How long would it take your friend to complete the yard work when working alone? Okay, so you'd hope that, when you work with someone else, that you work a little bit faster. They might not work at the same pace as you, but hopefully they get a little bit done, right? But if you have a really good friend and a hard worker, then you'll get things done in no time. So the setup right here is pretty simple. Okay, and how I tend to set things up is we'll have 3 fractions. Okay, and in these work problems, typically this is how it goes. There's you, your friend, or someone else. It doesn't have to be a friend, and that right there together equals your time together. Okay, so I always set it up looking something like this: 3 different terms, 3 different fractions, and we put it all together. Now, how do I put this all together? We have our work rate, and you could say that you, being one person, we'll put that over, or 1 yard, we'll put that over 5 hours, or the amount of time. Okay? Your friend, we don't know how long it takes your friend. That's what we're trying to find. So the friend still works on 1 yard. The amount of time it takes is unknown, so we'll go ahead and put T right there. How long does it take for you guys to do it together? Well, it says we could do it together in 3 hours. So we're not just going to put 3 right here. I'm going to go ahead and put 1 over 3. That 1 yard takes you guys 3 hours. And so now we have ourselves our rational function, or a rational equation, and then we can go ahead and solve this out. And just like that, it's pretty straightforward. Pretty easy, hopefully, right? We can go ahead and use the skills that we just learned to solve for t. We got to find what's the LCD right here. 5t and 3. Remember, you can multiply everything together, and that happens to work out to be our lowest common denominator, and it's 15t. So I have to multiply everything by 15t. So let's see what happens right here. I got 15t times 1/5. The 5 and the 15 will reduce. We got ourselves left is 3t. When we take 15t and multiply it by the friend, the t's will cancel out, and I got 15 times 1, and I'm left with 15. When we do things together, we got 15t times 1/3. The 3 and the 15 will reduce down or divide, and we get 5t. 5t times 1 is 5t. So let's go ahead right here. We'll Now we can solve for t, and we'll subtract 3t to both sides. And then right here, we'll divide both sides by 2. And t is equal to 15 over 2, or 7.5 hours, or 7 hours and 30 minutes. So make sure you know all of those right there. Okay? And there you go. How long will it take your friend to complete the yard work when working alone? Sadly, it's 7.5 hours. So they're not as good of a worker as you. Maybe a little lazy. Maybe they take too many breaks. Who knows? Uh, not everyone was built the same way. So I like to set up my problems like this, where we have three parts to our equation. You have you, your friend, and working together. And no matter how the setup is in these work problems, it's pretty much usually the same. So if you set it up like this, you should be in good shape. All right. I find it to be a lot easier than trying to work and use a table like how you see right here. All right. So there you have it. 7.5, solving rational equations. We are now done with chapter 7.